Good evening. Sorry for the delay. Okay, today let us discuss the phenomena of the fluid mechanics, particularly how that fluids behaves in the real world, maybe on planet Earth or maybe in the universe to a great extent. They are calling this one as the real of fluids. I mentioned in the title such a way that the Newtonian and non-Newtonian fluids not put together, they are having a different classifications, behaves in a different way where we can enjoy the things of the properties or the characteristic features of those kind of fluids in real-time applications. Maybe drinking a water from a cup or maybe a water bottle is a kind of a phenomena, but drinking a juice is another kind. But thing is that all of you might have enjoyed the ice creams in different flavor and ice creams in the different shapes and structures also is mainly because of the rheology of fluid mechanics, rheology of the fluids. Let us see one after the other, maybe in detail to a great extent in this class. This is the syllabus, okay, no issue. You are getting this type of a topic from my end, actually. My God, see that. I hope you are able to see this great shade. What is the fluid mechanics? What we discussed and came to a conclusion so far is that this fluid mechanics deals with the study of all kind of fluids under either static condition or maybe dynamic situation. Means if we keep a fluid without having its motion, without having its movement, without having its pressure or maybe a force which are acting on that, or maybe the forces acting on the fluid from all the directions might have conserved where the fluid is said to be static with reference to an observer, or maybe it will be dynamic also. It may be moving from place to place, moving from time to time to a great extent. But this fluid mechanics is the real branch of continuous mechanics. Continuous in the sense the properties are changing that deal with the relationship between different forces which are acting on the fluid, different motion of the fluids because of the various forces which are acting on the fluid and static conditions in a continuous material. Means it also deals with, or it also refers to, you can say that, many diversified problems such as surface tension, you are well aware of, fluid statistics, not statistics, statics actually. Static in the sense it is not moving with reference to the time, it is not moving with reference to the flow. Flow in enclosed bodies or flow round across the bodies, either solid or otherwise, whichever may be the shape you can expect it under the flow stability. In fact, what is happening is that almost in any action of a person, either from my side or from your side, or whoever is there on mankind on this earth, are doing, or these mankind's are involving in various kind of fluid mechanics problems, and it is a necessary criteria, and it is the most essential part for us to understand this phenomena in a better way for our purpose, for our applications, for our comfort, for our need, actually, in the sense. Why we need it? Because I will let you know the boundary between the solid mechanics, like classical mechanics, what you are expecting, movement of a vehicle, or movement of a car, movement of an aircraft, without considering the fluid. And the fluid mechanics, movement of the fluids in any dimension, either in a river or maybe a pipeline or maybe a canal, is some kind of a gray shed in the sense there is no sharp boundary, there is no sharp distinction between that. See, for example, if X reaches 20, it is liquid. If X reaches beyond 20, it's solid. You can't classify like that. Or you may be interchanging this in such a way, interchanging in such a way that it is of the two kind mode, online two kind mode actually, where you can't expect the relation between those things. Means there is no sharp boundary because there exists a complex relationship between different branches, and only part of it should be drawn at a time. In the sense, for example, if you take some kind of a glass for its study, it is having something. Or, for example, glass appears as a solid material, no doubt, but closerly, if you look into that, it reveals that glass is a liquid with large viscosity. For example, take the picture on the top, sorry, on the bottom left side actually, entire structure was made by, still it's made by, okay, made by a glass. which is bent into any kind of a shape. See that actually. Maybe there are some features. People are moving here and there. A person, whether you are watching on the just right path of it, is walking on a glass sheet, okay, made of some kind of a material. Imagine here in China, not it is an imagination, in China, they have built a bridge, over bridge between the two mountains, two great hills they can call, by a glass. A person was unable to move on that glass. He is an afraid of whether he can fall. Even they are moving the mini vehicles like a cars, two-wheelers, and four-wheelers of the known strength on this, where this glass withstands that pressure, withstands that force at a great height of about more than 500 meter, or some height actually. You can expect about a few hundred meters from the surface actually. You see that how you could have been watched or you might have watched already so far in video or maybe some other social media, or maybe you might have heard from the information such a way that glass can be used as a toughest material. Glass is not an easy job. Okay, glass is not an easy job. This how means glass behaves either liquid or maybe a solid of that kind. There are several materials of that kind where the properties can't be understood by a certain mechanism or by a fixed mechanism of that kind. Means to say that is it glass is a liquid? Yes, there is no doubt. At certain temperature, glass behaves as a liquid. Take the glass to a higher temperature, it converts to the liquid, and by blowing that liquid, you can make into any desired shape of solid glass. That is the right path is showing that the glass, not transparent material of anything. It is not an ice cube also actually. The right side picture shows that it is material of a glass, solid glass actually, solid material. Left side it can take into the any shape. It is not the one which is deformed. Glass can take any shape by its deformation. Means to say, pictures are better for understanding. At the same time, they also may be complicated issues. It's not an easy job. See, the study of these mechanics involves many fields that have no clear boundaries between them. Means you can take any examples, you can take any applications, you can enter into the any field, starting from the blood in a vessel to the plasmas in stars. You have to have the understanding of the relationship between the fluid mechanics and their branches. Okay, means researchers, scientists, and even the students at the various level understand and also classify them into a different classify them in an orderly flow and an chaotic flow. If the flow is very orderly flow, is a systematic flow, it is called laminar flow. The flow is not an orderly flow, okay, then we can call it as a turbulent flow. Means certainly students of all the master degree students from the physics background preferably can classify them which are the orderly flow, which are not orderly flow of that kind. Non-orderly means there is a chaos. Chaos in the sense they move in a random motion. They move in a randomly. There is no systematic way of flow. Okay, the chaos. This fluid mechanics can also be distinguished between a single phase flow and a multi-phase flow. Means to say that flow may be made of more than one phase or maybe a single distinguishable material only by glass or a mixture of several other material only by water and other kind of a liquid, maybe a liquid and other things, only by nitrogen gas, only by hydrogen gas, a mixture of nitrogen and hydrogen or hydrogen and sulfide, hydrogen sulfide, such type of things. Because of this, the last boundary or the whatever the boundary we are expecting, like all boundaries in fluid mechanics, what we are expecting is not very short because fluid can go through a phase change. Means fluid at different conditions of different pressure or different temperature have a different phases like that. It may convert from one phase to another phase. Means either in terms of the condensation or maybe an evaporation in the middle or maybe during the flow, and it can switch from single phase to a multi-phase. We will see that. I will give some proper examples to convince you in this class. Means to say that flow with two phases can be treated as a single phase. For example, A atmospheric air made up of nitrogen, gaseous molecules, oxygen, gaseous molecules, argon, gaseous molecules. That is why it is called the gas envelope. about 99.99%. There are some dust particles. They will call it as an aerosols, suits. Okay, suit in SO2, NOx, carbon particles of the carbon, particles of the sulfur, particles of the so many things. It is a material property. Atmospheric air is also made up of that. And see, if you bring them, put them together, actually, can be treated as a single phase. If you want to understand that how air flows, how wind flows from one point to another point, you have to understand the combination of these two phases from one to each other. If you on the right hand, you can see a flow chart. Strictly, it is a continuous mechanics, what we are studying actually. First part was done by your, still it is maybe going on with the faculty who is teaching the continuous mechanics of that kind. I am studying with the continuous, continuous mechanics. There exists in solid mechanics, means you can study the properties of the material if they are in static or maybe in motion for the solids. But there is a fluid mechanics, there is no doubt. Where the fluid mechanics deals with that, the density of the material does not remain constant. Density varies. Density changes as a function of temperature or maybe as a function of the pressure for a kind of a fluids. It need not be for the solids. For the solids, for all kind of solids, density remains constant. Density remains constant irrespective of the pressure to a great extent. You can't compress them, period. They are not compressible thing. But fluids are compressible. You can't make them as an incompressible. There exists something in between. There exists some study in between solid mechanics and fluid mechanics. That something between is dealt by continuous mechanics, which changes from solid to the fluid, or maybe from fluid to the solid, either the way, where your role of studying those kind of a property in your class, in your curricula is most essential. Solid mechanics, I will leave apart for you because you studied so much of mechanics so far till your third semester of the course and also in undergraduate courses. As far as the fluid mechanics is considered, you see, we are going because the examples and the relevant information you should be well aware of it actually. Okay, means can be classified or can be distinguished by the fluid statics or maybe fluid in dynamics. If we keep a cup of water or a water in a cup, fluid is at static. In the sense, fluid is not moving at all. If the same fluid is moving, in the sense, for example, if you raise the temperature of for a glass cup of water, the fluid starts moving from lower surface of the water bottle, sorry, a cup of glass, or maybe to the upper surface by absorbing the energy and making it convection for the flow from always it has to transport the energy from the higher energy to the lower point. Means to say that hot air or hot material will be moved towards the cold, and there will be an exchange of the energy between the hotter bodies and the colder bodies unless they reach the equilibrium. Here in this fluid statics, you can have the multi-phase, there is no doubt, or you can also having the stability problem. Two classifications you can expect. But the fluid dynamics shows in such a way, fluid dynamics is also having a multi-phase problem. It is also having a stability problem. But in addition to that, there exists a boundary problem. Means to say that between these two, stability to the multi-phase, there exists some boundary. In between, you can expect that actually that boundary problems were dealt by both fluid mechanics and the fluid dynamics. This fluid mechanics, there is a conjunction internal. How it has to happen? It has to happen by the internal flow. Means to say that the flow may be a laminar flow if the this is you see that reason. Laminar flow means to say that a small part with the stability problem, but multi-phase has to accept it. But if it is a turbulent flow, it is the combination of multi-phase, stability problem, and boundary problems along with the internal flow. Means to say that it becomes a complex and complicated to understand. There is no way, but we can try to understand the phenomena from simple to the complicated by understanding one after the other. Because of this, the two scientists yesterday, or maybe day before yesterday, I mentioned about their introductory part in such a way that Navier and Stokes, they are different scientists. Navier at the molecular level, worked out at the molecular level, and later Stokes from the continuous point of view of succeeding the creating the governing equations or the fundamental equations or very basic equations for real fluid motion. Means the Navier work for the molecular level, how that molecules will move, will be drifted, will be transporting the energy, how that can happen from one phase to the another phase or from one region to the another region was theoretized by, conceptualized by a set of equations from Stokes, thus, which can creating a matching between an experimental work of Navier and a theoretical approach of the Stokes put together, how that fluids can move. As a result, it created a strange name. Earlier, that name was not there. People were believing that hydrology means study of the fluid, preferably water, preferably some kind of a liquid. Maybe in aerology, only for the air. Maybe some dynamic gas dynamics they can call actually only gas. It's study of the gas actually. Here the name is combined with hydrodynamics. Hydro is also going with the dynamics. Hydraulics, because the putting the pressure and other things, all suspensions are working on the hydraulics, particularly preferably by the air, where the two-wheelers were maybe having an aerodynamics, gas dynamics, aeronautics. Even you can apply the brakes not by the virtue of the friction, by the change in the pressure inside the what shaft you can bring the moving vehicle to an static or moving you can reduce the speed of the vehicle to a static value of that kind. All JCB missions, all huge missions works on the hydraulics, even gas dynamics. Maybe if you allow the gas to move very fast, it may have different kind of energy. Even in aeronautics, it is not easier job. Now the aviation has started. The space journey also started mainly by the aeronautics. In the sense, the transport through the air media, particularly either from aircraft, helicopter, or whatever maybe the jet planes, is happening mainly because of the achievement of the technology in the aeronautics. Based on this, good. Same classification. I'm not deviating from this, but still further to classify here. This you can say that if you allow the fluid to pass through, earlier picture, the beginning of was not to be reversed. If you allow them, it will expand and it can occupy the same thing. One can expect that the speed times time may be given by the S1, how much distance it can cover. Here, speed times time can be given by the S2, it has to cover because it is covering the larger cross section and the same amount of the fluid will be transported from one point to the another point. It also depends on the potential energy from the surface. From the surface, how far it is there. Okay, if you lift it in reverse, means you can allow the fluid from the region 2 to the region 1 on very freely. If you want to take it from here to here, you have to have some kind of an energy that will think it up later. Here, this is nothing but a material glass is filled with either partially or maybe fully to a great extent with some kind of liquid, that is assumed that water. These are the pebbles, stones, which were taken a very good shape, very smooth surface with different textures actually. As soon as if you see the diagram, you may feel to have such type of things in your home or room or hostels because of such an attractive shapes, such an blooming shapes of that kind. Okay, this I don't want to show you that. Maybe your mouth may be watering actually. I can't offer you because you are attending the online classes. Even offline class also it is very difficult task. If you plan any kind of a scientific trip to the ISRO or maybe any kind of the organizations, if there is a possibility for such type of a trip, certainly I will take you. I'll take you to one of the shop to offer these type of things. Why it is happening? I will let you know here. This continuous mechanics is the one which can give you the study of the continuous materials or physics of the continuous materials. There is no way means to have to move from one point to the another point, but that can be broadly classified into either fluid mechanics or maybe a solid mechanics. In solid mechanics, it leads with the elasticity. You might have studied Hooke's law. You might have studied the different kind of a laws. For example, what you can call Young's modulus, bulk modulus, rigidity modulus, and so much of moduli. Each material is having their own fixed properties. Depending on their property, they can say that what must be the kind of a material. For example, if rigidity modulus is an X, can I use it for an iron rod, iron beam of that kind? Can I use it for a railway track? Can I use it for any kind of a material to make into the railway track, to make into an, for example, body of the aircraft, body of the vehicle, or maybe can I use it for some kind of an container where that can hold highly pressurized gases. For example, the cylinders may be used for the cooking gas or maybe any other type of things. They are very heavy. The weight may be about more than 50 kilogram. But how much gas they will fill inside the inside the cylinders for cooking LPG gas of that kind? Maybe hardly about 15 kg. Means why their container should be such a heavy in the sense it should be a double coat, not coated actually, double layer or triple layer, where it has to sustain the high pressure. Even you might have watched the or witnessed the regulators. Don't play with those kind of regulators for cooking gas. It will come with very high force. Okay, maybe some materials, maybe in plastic materials, plastic in the sense maybe water bottle or maybe such type of material where it will not regain its original shape after the crunch, after they get its deformed. In our fluid mechanics, I told this because this is you are aware of it. In fluid mechanics, what is happening actually? The study of the physics of continuous material, no doubt, which takes the shape of the container. That's the only difference, which takes the shape of the container. Means here, Newtonian and non-Newtonian laws are very much valid. The liquid fluids which obey the Newtonian are called the Newtonian fluids, which doesn't have non-Newtonian. But thing is that here, non-Newtonian fluids and plastic city material or plastic material have some common phenomena, some common process which are happening. Those materials or the study of the materials with both solid and fluid characteristics are known as the material which obey the rheology. Rheology you can enjoy in such a way that here rheology is a phenomena achieved by all kind of juice, shakes, milkshakes, ice creams with these different flavors, except the fruits, vegetables, and other things what have kept it. Here we go, or we are informed, our consumers are informed, for instance, that the products are thick. They are thick means they are also thick and creamy. Okay, you have to achieve the two properties together. It should be very thick and it should be creamy. See, for example, you might have enjoyed the cakes. Okay, any kind of pastries. If it is with creamy, if some temperature goes up, it will has to melt, but it should be very thick. Both properties should be achieved in the same material, as well as there should be new thing and an improved thing because such rheological properties are more pleasing to the eye and mouth, and you pay an hectic amount to enjoy that. There is no doubt. There is no doubt out of it. Means to say that, and you can enjoy those things also, but to achieve that state, to make your ice cream both the creamy and crispy, creamy and the thick of that kind, it requires the understanding of study. So, because if you take an ice cube, even if you crush into the powder of an ice, powder in the sense very fine cubes, it may be melting, but how can you make it as an ice cream actually? Ice and cream, both should be appeared at the same point. That phenomenon is known as the rheology. Can enjoy this to a great extent. Means to say, there are several kinds of fluids. Just I'm going through that. Don't worry, it's not an issue. Some differentiate fluid from solid by the reaction to the stress. If you apply a stress, if it gets deformed, it is a fluid. If not, it is a solid. It is known as, it is a known fact that fluid continuously and permanently deform under the shear stress, while solid exhibits a finite deformation. Of course, if you apply huge pressure, there may be some finite which does not change with the time. For example, if you are having a cork ball, if you apply so much huge pressure, certainly it may change its shape. Okay. It is also said that foods cannot retain to their original state after the deformation. You may deform the fluid, but it will not come back to the original position. Like plastics, like elastic material. Maybe eraser you may be having in your with you actually. You just press their rubber bodies, it will reach the shapes will be regained. Means this differentiation creates a new material group that show dual behavior, like particle behavior and wave behavior for the electromagnetic radiation. This material will also show a dual behavior under certain limits or under certain conditions. It behaves like a solid and other two, it behaves like a fluid to a great extent. This study of this kind of a material is called rheology. When a fluid is at rest, no shear stress is applied. Means to say, this rheology is in such a way If the fluid is at rest, no pressure, no stress is applied. If the stress becomes zero, the fluid will be at rest. If the stress is increasing, fluid should be under motion. Means fluid is mainly classified either into the liquid and gases. The difference between liquid and gas states is that gas will occupy the entire volume while liquid have an almost fixed volume depending on the content. The difference between gas phase to the liquid phase above critical point is practically minor. Means above some critical point if you go, there is no difference between the gas and liquid. In the sense, the same water may be converted to the water vapor. Water also exists in the form of a vapor, both act like a vapor state. But below a critical point, a change of water pressure by about 1000%, for example. Let us take 1 liter of water bottle with water, not in a bottle, okay, with some system, some container, increase the pressure by 1000 times. Okay, it changes the volume by less than 1%. You can't compress it to it. It is an incompressible fluid. It is an incompressible liquid. For example, a change in the volume by more than 5%, if you expect it, it requires more than 10,000% of the pressure. So if the change of the pressure is so significantly less than that, then the change of volume is at best 5%. Hence, the pressure will not affect the volume for the liquids. In gaseous phase, any change in pressure or even a small change in pressure directly affects the volume. The gas fills the volume and the liquid can't fill the volume. Gas has no free surface or no intermediate surface, but this does fill the entire volume, but the liquid will fill that. This should be. That's why the fluids matters. Simply, the different power of fluid families are in such a way that rate of change of the fluid with distance, if you expect on the left axis, okay, this is the shear stress. If the rate increases by this way, those materials are called the dilatants. This kind of a property is achieved by the thixotropic material of fluid. And the green color is in such a way, whenever if you apply a force stress corresponding to the stress, it gets the twin wish, you can call it as the Newtonian fluid. This we are well aware. Non-Newtonian, rest of them are the non-Newtonian, okay, except the green color. Means if you think of this pink, actually, this is the pseudoplastic. Okay, takes the shape, it is not linear, it is taking. The Riemann fill-up is another kind, actually. It increases up to this extent, then changes its position. This is the rheoptic material of that. This is the below the Newtonian, this is the above the Newtonian. But here, you see that even del U by del X rate of change of material becomes zero. They are stationary. You can have some stress which is acting on that. That material is known as the simple Bingham material. You might have witnessed it, or maybe I don't know, maybe you are so grateful enough in witnessing, or you might have heard that people are walking on water, people are walking on lake, people are walking on ocean, people are walking on seashore. Seashore, there is no point on a sand. People are walking somewhere else. That I will let you know in the few classes. Water density as a function of temperature for various pressures, how it has to happen. You see that as the temperature goes up, the density has to drop. Okay, density will drop in such a way, rate of change of the pressure with the density is in such a way that, see, it is increasing to a great extent. Okay, density of all the liquids it drops, but if you increase this ratio, it may be different actually. Means as the temperature goes up, the density, as the temperature goes up, the density drops to a great extent. See, here to here, you can't expect almost linear, but here you see that how much gradient you are expecting actually. Means here you also come across with the material with some surface tension that mainly depends on the properties of the cohesion and adhesion. In the sense, cohesion means there should be an intermolecular attraction between the molecules of the same liquid. Okay, it enables a liquid to resist the small amount of the stresses. This cohesion is a tendency of the liquid to remain as one assemblage of particles. Therefore, surface tension is due to the cohesion between the particles at free surface. Means you might have taken a capillary tube and hollow the water. Water rises on its own because of the surface tension. But the liquid will never adhere to the substance. Adhesion is in such a way. Adhesion means attraction between the molecules with the liquid and a solid boundary surface in contact with liquid. Therefore, this property enables a liquid to stick to the body. For example, capillary action is due to both cohesion and adhesion, but it may not adhere. Surface tension is mainly caused by the force of cohesion, the first one, at the free surface. A liquid molecule in the interior of the liquid mass is surrounded by another kind of a molecule like a solid around and in equilibrium. At the free surface of the liquid, there are no liquid molecules above the surface to balance the force of the molecules below it, and the liquid has to flow. Means otherwise, if you are expecting the rise in the temperature of a thermometer by the movement of the mercury by the absorption, the same thing will happen here. Fluid and surface tension, I mentioned actually. See that water is having a different surface tension. It is a function of the temperature. Okay, but glycerin having some value. The same soil as having oil as having something. Mercury is having something. Kerosene is having something. It is only for your reference actually. Because of this, there are existent types of flow. Maybe you can classify them as the compressible and incompressible flows. Liquids are not compressible, gases are compressible. Any an incompressible flow is a flow which variation of density within the flow can be considered. Here, rate of change of density with the time, if it is happening, compressible. If it does not, incompressible. You can say that flow should be an either steady flow or maybe an unsteady flow. A steady flow is the only one which velocity does not depend on time. It can move constantly. When the velocity varies with respect to the time and also the flow is called it unsteady. Here, see that something is falling. Is it a laminar? No. You can classify them laminar and turbulent flow. That here that it is a laminar flow. Flow of an ink in a refill is a laminar flow. Flow of an gas molecules in the air, a turbulent. Flow of the liquid boiling water, you can call it is not turbulent actually. See that looks like a laminar flow hot storm. See here, it is not like that. It is a turbulent flow. It is mixing with well of that. Just maybe you can read for just for understanding. Being these things, fluids can be classified into ideal fluids. This is the line, which is incompressible and having no viscosity. All fluids have some viscosity. Ideally, no fluid exists without viscosity. Real fluids are the one which possess viscosity and is known as the real fluid. All the fluids in actual practice are real fluids. You can't expect an ideal fluid. Newtonian fluids has to obey the Newtonian law. See that this is the one. Okay, ideal fluid is the zero. This is an ideal solid y-axis. Ideal fluid is on x. Okay, okay. Newtonian fluid. Non-Newtonian or rest of them. This is a non-Newtonian fluid of that kind. If it is a ideal plastic, even with del u by del y is zero, it has to have some shear stress. Ideal plastic fluid of that kind. Because of that, we are getting the rheogram of various fluids, what I mentioned. From the origin, rate of change of this velocity or the speed with time gives you the stress in such a way. For the air, this is the value. For the water is higher than the air because it is a mixture of those things. Oil with more viscosity still having higher value. Glycerin is having still ratio of mu by I. You can take should be more. Slope increases. Means as you are moving from gaseous material to the liquid and maybe to the solid to the y-axis. If you take the diagram of the non-Newtonian fluids here, these are Newtonian fluids at the left side. This is the dilatant material. Dash one is the Newtonian. This is the pseudoplastic. Earlier also I mentioned this yield the dilatants. This is having some value and Bingham plastics. These are some kind of a properties one has to understand. Based on that, Navier and Stokes have developed some set of an equations that should be understood well by the different research community and also by the curricula to a great extent. If you're having some queries, I'm very happy to answer you. Otherwise, this is my last slide for today's class. Any particular queries? Otherwise, I'll stop sharing.